partial pressures, or if you haven't seen it before, I'm going to tell you everything you need to know about partial pressures. So here's a little review, or for the first time, description of partial pressure. So what is the definition? The partial pressure is the pressure that each gas would exert if it were present alone in the container. So in this example, we have oxygen in a container, and we have 1 atmosphere of pressure. In the second one, there's nitrogen in a container with 1 atmosphere of pressure. If you put this amount of oxygen and this amount of nitrogen together in a container, then you would have 2 atmospheres of total pressure, but you're still going to have 1 atmosphere of partial pressure for oxygen and 1 atmosphere of partial pressure for nitrogen. So it's as if the gas is alone in the container. That's the definition of partial pressure. So let's look at some equations. So the partial pressure of a gas, P to sub A, is equal to the number of moles of that gas. And we also have in this equation R, our gas constant, T, our temperature, and V, our volume. The total pressure on the system, which is what this 2 atmospheres is equal to the partial pressure of gas A, which would be the partial pressure of the oxygen at 1 atmosphere, the partial pressure of the nitrogen at 1 atmosphere. That's all we have here. So the partial pressure of those 2, of 1 plus 1, we have 2 for total. And that's equal to the total number of moles. So in these problems, we're going to be considering partial pressure. And the question you're going to be asking yourself in all of these different wordings of the question is the partial pressure of the gas changing? That's a very important question to ask because that'll help you answer the questions correctly. So let's go back to the original question. What happens if an inert gas is added to the container, increasing the total pressure at constant temperature? And the answer is nothing because Q is not affected, because Q depends on the partial pressures, and the partial pressure isn't changing. We aren't changing the number of moles of the gas in question. We're just changing the total pressure of the system. We're adding an inert gas. And because partial pressures don't change, Q doesn't change. And if Q doesn't change, there's no response from the system. So a lot of the questions in this system, they're not in this unit, they're not actually very difficult, but the wording can be tricky. And so when you're doing these problems, you have to be thinking about what is changing and what isn't changing to be able to get these questions correct. And if you do that, then these are some nice questions for you to get right on the exams. They're short. They're good questions to go after. All right. Let's see how you're doing with it.